ever go about your day and start questioning, what is reality? Do we see what we actually see? And what limitations are we as a human species are capable of doing, finding, and seeing with the naked eye? The world is so vast that our human minds simply cannot comprehend our existence. Hence why we have existential crises.
Am I real? Who am I?
At this very moment, I'm in a floating rock. Why am I even reading?
But I digress. When we question our existence, we also question, what are we made of? Or where did we come from? Most building blocks of matter are made of the fundamental units called atoms. Atoms are such a complex system that we also begin to wonder, how do we even manage to discover them or observe their behavior? Before we dive into the complicated things, we need to figure out, what does an atom look like and how is it structured? An atom is essentially a particle of matter that uniquely defines a chemical element. It consists of a central nucleus that is surrounded by one or more negatively charged electrons. Protons and neutrons make up the nucleus of an atom and the electron's orbit. The more photons that the electron absorbs, the higher the electron's energy would be, therefore creating a much more relevant wavelength. Speaking about waves, electrons are also waves, just as it is a particle. In quantum mechanics, particles behave in groups, creating wave-like data. To detect such waves, a breakthrough in physics was made in 1925 when a physicist named Schrödinger made an equation on how to decipher waves on a graph in sound and electronically. Schrödinger making this equation made the electron's behavior possible to observe, making the world seem less complicated and more predictable. Things like electronic devices, electromagnetic radios, Wi-Fi, audio signals, and voice communications that we use today are possible because of this wave detecting equation. Now let's quickly go over the structure of the Schrödinger equation. To put it in simple terms, this whole equation is the sum of the wave equation's kinetic energy and potential energy equal the wave function's total energy. The h, or the Hamiltonian operator, is the total energy of a particle, followed with the Greek letter psi, which is the wave function. Alright, now let's get to the fun stuff. An electron can essentially be excited and not excited at the same time. When it is measured, only one of the states would be able to be recorded and observed. This creates a theory called the electron observation theory. It questions if reality is altered when not seen. The electron can simultaneously be everywhere that the wave function says it can be. In other words, you could catch the atom at both states, but in conclusion, only one would be able to be observed randomly. This makes us question if everything we see is immediately altered when we look away. So next time you go to bed, make sure you keep one eye open for those sneaky electrons.